Hello everyone, this is Group 1 from 56601 RTOS. I'm Jacob Shebesh. With me I have Youssef Souryal, Justin Edwards, and Vincent Crabtree. We're going to be showing off our home sensory system. We're going to start with two 9-volt batteries, and this is going to feed into a voltage regulator that will distribute 5 volts or 3.3 volts depending on the peripheral's needs, starting with the ESP32 in the center. And then on the side we have LEDs that will light up in hazardous conditions, an LCD screen that will display the text values of all the sensors on the board. And then we have the particle sensor on the top, which will show the purity of the air. Then we have the MQ7 carbon monoxide over here showing the toxicity. And then we have a DHT11 that will show off the heat and humidity of the system. And then we also have a photoresistor to simulate how much light there is in the room. And then I'll just power it on for you.
Okay, here's the system in action. So as you can see, the LCD cycles through. You can see the particle value and the temperature value right there. Then there's the humidity value. And then soon the time will show up. So that's the time, the current time right now. It's just cycling through the things to display. Then the photo resistor is at 100% since the lights are on. Gas value, showing all that. All right.
So now we're displaying the functionality of the LCD. So the LCD uses the I2C protocol to display the data, and there are 4 wires connected to it. There is the power, there's the ground, there is SCL, which is the serial clock, and there's SDA, which is the serial data. The one we have here is 2 by 16 bits, and the data is being transferred through bit 0 for your information. And here we have the pages switching every 5 seconds. So we have a screen just for the time and date, and this utilizes the SNTP, and we get the value over from the Wi-Fi, which is a mobile hotspot that we use. We get the connection to the Wi-Fi, and then we get the time and the date through it. And then we have some other screens that show the values of the gas sensor, the photo sensor in one page. We have another one that shows the particle and temperature sensors, and we have a third one that shows the humidity sensor. The functionality of some of the components of our home sensor system, and we're gonna be doing the carbon monoxide MQ7 sensor and the DHT11 temperature and humidity sensor. So we're going to be getting with the temperature as 91.4, and we're going to be displaying the gas value initially, and then the page after the clock. And we are going to be restarting the system after heating the sensors and the sensor just to get higher values, because the system is weighted average, so we have to do this because as long as it's running, it's just counting and building an average value. So we're going to restart it to get the latest and best value that we have currently. So we're going to be doing this process now. So we're going to be heating up using a heating blow dryer. That's enough. So we're going to be restarting the system and looking at the values going up. So it's just starting now. We can see the temperature went up to 138.2 from 91.4, and the humidity
The introduction for the MQTT. We're going to restart the system really quick. And this is going to be showing that it's going through and flashing it and then updating all of the values on the screen. And then if we come over here, all these values are being sent to the MQTT server, and we're just going to show that it's updating. And it should be updating about every 5 seconds currently. And there you go.
All right, this is for the serial connection part of our project. So you start by typing log on, and then it asks for the password, which in this case is just password. And it'll encrypt it and check it against the password that's stored in non-volatile storage. In this case, we got it correct. Then the little $sign will show up showing that our shell is ready for user commands. So the two commands are set and log. We already showed log on. If you type set, it'll show you everything that's currently stored in non-volatile storage. So like SSID, password, system ID for the system. And then you can also use set to make a new variable. So if you say a equals 4, then you check again. Now it's saved in the non-volatile storage. So we can say f equals 7 and set, and now that's also there. And then you can type in things. It'll say invalid if it's not correct. And if you want to disable the serial connection, you can type in log off, and then it disables it. And then if you type log on again, it asks for the password again. That's the wrong password, but then we're back in. Be a demonstration of the manager task and its functionality. So what we have here is test code on the screen, which is just printing off the values that the manager task takes off of a shared FIFO queue, which is just a free RTOS queue. So each sensor task has its own individual task, and it interfaces with the sensor using wrapper functions such as dopen, dread, dwrite, dcontrol, dclose. They all use the same functions using file descriptors, which are passed to the file table, which has function pointers specific to each sensor. So when a sensor function calls the dread, for example, it will read the value from the sensor, and then it will place it on the shared FIFO buffer. And on the other end of that, the manager will pop it off of the buffer, and then it will parse the data, which is being shown here. Using that, so we'll see if it's particle, gas, temp, humid, determine which one it is, and then use that to calculate the exponential weighted moving average. This average will be placed in an environment variable, which is accessible by the communication task or the command task, and it will also use these values to update the system signature, which will place a very low, low, normal, high, or very high value for each sensor, so the command task can use that signature to determine which actuation equipment to turn on.
Our software completely implements the project and all of its components. It might not be displayed properly on this system just because of the soldering and some wiring and connectivity issues, but if this whole system gets transferred on a breadboard, it will function properly with no faults. Specifically with the LEDs and how there are some connectivity issues with with powering them and putting resistors. But overall, everything works perfectly on code if it's moved to the breadboard.